Okay, I think you have finished the question. And now I will show you my answer. But first one, let's analyze the information which are given in this question. In a study of male serum cholesterol, 200 individuals are randomly drawn and the mean is 3.64. Assume we know the standard deviation of the population is 1.2. Calculate the 95% confidence interval of the mean. Here, let's think about it. This number, this is the n, yes, this is n. And this is x bar, yes, the sample mean. And here, the right words is the standard deviation. So that means, what's the meaning of this right words? That means the standard deviation is given. Yes. So when standard deviation is given, we can use the method based on z distribution. Yes. So here, sigma is 1.2 and 95% confidence interval. That means alpha equals to 0.05, and we can also know z half alpha equals to minus 1.96. So we just put all the numbers into the formula, right? Okay, so here this is the formula, and we put all the numbers into the formula. And we can get these two numbers, 3.47 and 3.81. So that means the 95% confidence interval is between 3.47 and 3.81 with its corresponding unit. So do you get the correct answer? I think you can do that. Okay, next one, another exercise. And this time I won't give you the time to practice. I will show you my answer. I will show you my answer, and you just think about the answer, the procedure of the answer to this question in your mind, and I will show you my answer. So let's read the question first. In a survey of Jinzhou City in 2004, the mean of the height of 110 years old boys is 147.10 centimeters. If we know sigma is 5.67 centimeters, try to calculate the 95% confidence interval. So here, it's still a question about confidence interval, and it's still the same probability, 95%. So z equals to negative 1.96, right? And sigma is given, so we can use the method based on z distribution. And here, this is the little n. This is the x bar. So it's very simple, right? We identified all the numbers in the question, and we have already know the formula, and we just put all the numbers into the formula, and then we can get the answer, right? Okay, so I think it's not difficult for you. So here we put all the numbers into the formula, and finally we get the answer. That is 95% confidence interval is between 142.09 and 144.11 centimeter. We can find that, we can notice that there is an unit for the confidence interval, right? Okay, so that is the method based on z distribution. We use z value to solve the questions about hypothesis testing, about the one sample hypothesis testing. And we also use z value to solve the questions about estimation, about the 1 minus alpha confidence interval, right? Yes. Okay, so here, please notice that the boundaries of the confidence interval depends on the values of x bar and s. Especially in this kind of method, it most often depends on the x bar because we use sigma actually. So if the confidence interval depends on the value of x bar, that means the confidence interval can vary from sample to sample. So that means even from the same population, we draw different samples and we can get different confidence intervals. So the confidence interval, any single confidence interval, is not completely correct. And we said that it has the probability to correctly include the population mean in the range, and the probability should be 1 minus alpha, not 100%, right? And the second one, there is a probability of 1 minus alpha that the interval will contain mu. We have just explained what's the meaning of this. And next one, when n increases, the width of confidence interval decrease. I think it's not difficult to understand. Let's think about the formula. This is the lower bound. This is the upper bound. So we find that when n increase, sigma over square root n should be decreased. So this number should be decreased, and x bar minus this decreased number, this one should be increased. So the width actually means the difference between the upper bound and the lower bound. So when n increases, the difference between these two numbers, these two boundaries, the difference between these two boundaries should be decreased. Yes. So the width of confidence interval decreases. Yes. When sigma increase, and that is similar with what happened in the third one, the width should be increased. And when alpha increase, so what's the meaning of alpha increase? Let's think about z half alpha. When alpha increases, the z half alpha should be decreased. Yes. So the width of confidence interval, or we can say the difference between the two boundaries of the confidence interval, should decrease. Yes. So that's very special in confidence interval. And there is some special relationship between hypothesis testing and confidence interval. So when we use the hypothesis testing method, if we reject H0 with the level of confidence interval alpha, and at the same time we use the same number to calculate the 1 minus alpha confidence interval for mu, we will find that the confidence interval does not contain the number of mu 0. So that's very special. So if the confidence interval contains the number of mu 0 that is the same with the H0 statement. So they are the same. But if the range is not contained mu 0 that is the same with HA, mu is not equal to mu 0. So that means there is some very special relationship between hypothesis testing and confidence interval. And we can use the result of confidence interval to test if we had the correct answer in the hypothesis testing. But there is still some difference between these two methods, hypothesis testing and confidence interval. In confidence interval, we can know the range of the mu at some special probability, but we can get that from the hypothesis testing. But in hypothesis testing, we can know what is the probability to reject or not reject H0. So that's it. There is something different between these two methods. Okay, so today we are talking about one sample statistical inference based on z-test. We have talked about two methods. The first one is one sample test of hypothesis testing based on z-test. And the precondition should be one sample, and X bar follows a normal distribution, and the most important is sigma is given or variance is given. And we have also learned another method, that is confidence interval. And we also use the method based on z distribution. And the precondition are almost the same. That is sigma is given or variance is given, and X bar follows a normal distribution. But if X bar doesn't follow a normal distribution, how can we solve the question about that? So at that time, we need to use another method that is based on a new distribution, what we call it T distribution. T distribution. So that is what we will learn in next class. That is about one sample t-test. So that's all for today's class. See you soon.